All right, good morning, everyone. Today is April 14th, and this is geometry. So a few class rules. Let's make sure to be respectful of others. Only use the annotation and chat features when asked. If you have a question, go ahead and raise your hand. You can raise it on the screen just like this, or if not, where it says participants on your screen. If you click on that, you'll be able to select the raise hand feature. And as always, do your best. A few tips: make sure to have a notebook/paper. So you could either have a notebook or a piece of paper, and then have a pencil ready for notes. If possible, try to find some quiet space. I know that can be a bit difficult, but just do your best with finding some quiet space for you to be able to focus. Ask questions, and then make sure to attend office hours if you do have any additional questions that you weren't able to ask, or if you need help with any assignments. Okay, as always, we're going to do a little stress check, so make sure that you, if you're watching this, you can go ahead and comment on Schoology how you're feeling. Are you at a 0? Are you at a 1? Those are that you're in a good space and you can focus. Are you somewhere in the middle? Something's maybe bothering you, but you can still focus. Or maybe you're at a 10 where you can't manage your emotions or behaviors right now. So the objectives for today, Tuesday, April 14th, are that you will review the 3 trigonometric functions. So you'll review sine, cosine, and tangent for a given angle in a right triangle. And then we're going to go ahead and learn and apply the Pythagorean theorem. So let's go ahead and review the do now that was due today. So the do now for today is April 14th. So hopefully you got a chance to complete this already. And if you didn't, after this class, go ahead and get that done, but we will review it, so at least it'll give you an idea of how to solve those problems. The first question's like this. It's label the right triangle based on the angle. So the first thing what you're going to do is we're going to look at this triangle. Notice it's a right triangle because it does have this little indicator that it is a 90-degree angle, which makes it a right triangle. Now, if you look at this, right here, this is our focus angle. So our focus angle, called angle theta, is this one right here at the top. So we need to pay careful attention when labeling our triangle. So right away, I know that the side that is opposite of the right triangle, and let me make some notes on this so you can see what I mean by that. The side that is opposite of the right triangle is always the hypotenuse. Okay. Always a hypotenuse. So right away you find your right angle, look at the side that's across that angle, and that is your hypotenuse. Now we focus on the focus angle. So right away I look at what's across the focus angle, and that will always be the opposite side. And whatever is touching it but isn't across is called the adjacent angle. So notice that was my opposite side, and that's my adjacent side. Now, for the second question for your do now, you were asked to find the sine, cosine, tangent of these angles. So looking at sine of A, and you would not, you didn't need to reduce or simplify anything as long as you leave it as is. It's more about being able to identify the sides. So sine A, if I remember correct, hopefully you remembered correctly that it's SOHCAHTOA. I always write it down just to help me remember. So if I have SOHCAHTOA, what that helps me remember is that sine is opposite and hypotenuse. So I look at focus angle A, we're focusing on angle A. What's on the opposite? That would be 36. I'm going to put it here just so I kind of remember. And then hypotenuse. Our hypotenuse is that 45 length side. Now let's look at our cosine. Cosine of A. So cosine is adjacent and hypotenuse. So let's look at A. Cosine, what's adjacent? The 27. And again, what's my hypotenuse? I already know based on that last one that it's 45. Next is our tangent of A. So again, I still look at A, and then this time I focus on the opposite and adjacent sides. So what's opposite of A? And this one, what's adjacent, meaning what's touching it, but it's not the hypotenuse. So that would be the 27. And then last but not least, tangent of C. So again, we look at opposite. So what's opposite? And what's adjacent, so what's touching it but is not the hypotenuse, and that would be 36. The reason I put it here on the side was because this is what it looks like on your on Schoology. So I wanted to show you how this works just in case you weren't sure. So it gives you a few options here. So you have to click on it and you drag it to its right place. So for example, for sine of A, if my answer is 36 out of 45, or 36 over 45, I look for 36 over 45, I would click on it and I would move it to that space. So it would look like that. For cosine of A, if it's 27 over 45, again, I just click on it, hold it, and then I move it. Tangent of A, hopefully you're starting to see how this type of problem works. 36 over 27, so I look for the 36 over 27. Again, click on it and I move it. And last but not least, tangent of C. So if it's 27 over 36, again, I click it and I move it into that space. And that'll be a complete answer. So that's it for your do now. If you do have any questions, make sure to pop in during office hours. But as always, you can retake this as many times as you need. So if you did not get the score you wanted the first time, go ahead and retake it. All right, let's look at this baseball problem. So a baseball scout uses many different tests to determine whether or not to draft a particular player. One test for catchers is to see how quickly they can throw a baseball from home plate to second base. So let me go ahead and show you bases. Home base. I'll mark that home. And then, so one test again is to see how quickly they can throw from home plate to second base, because it goes they go from here, 1, 2, and 3. So again, one test, it says it's from home to second. Notice that red line. The scout must know the distance between the two bases in case a player cannot be tested on a baseball diamond. So again, we need to know how, in case they don't have access to this baseball diamond, you need to be able to know, well, how far that is. This distance can be found by separating the baseball diamond into two right triangles. Notice this is a triangle and this is a triangle. And these are right angles. That will help us find this distance. We'll come back to this problem after our lesson once we're able to solve it. So let's look at a right triangle. A right triangle is a triangle with one right angle. So again, it has this indicator that it is a right angle. Oh, wrong, sorry. The hypotenuse is the side opposite the right angle and the longest side of the right triangle. So opposite of the right angle, and it's also our longest side. Notice it's longer than the other sides. So that's the hypotenuse. And then the legs, I know we usually call them sides. Another name for them are legs. So that's either the two sides that form the right triangle. So notice we have not labeled this side or that side. Those can be called legs, the legs of the triangle. Now that we know the names and the different parts of the right angle, let's go ahead and look at the Pythagorean theorem. So in a right triangle, if A and B are the measures of the legs, so notice it tells me A is on this leg, B is on this leg. So that tells us how long this is going to be. We just don't know those values yet. C is a measure of the hypotenuse. So I'm not sure if hopefully you're able to see that. Let me just move my box because I can't see it. Okay. So C is on the hypotenuse. So if we have the measures of A, B, and C, then the Pythagorean theorem is this formula. A squared plus B squared is equal to C squared. That's because if you square this value, you square that value, and you add them together, it should be equal to the same length, or it should be equal to this value squared. As a reminder, squared means you take a number and you multiply it by itself. So just as a quick example, 3 squared would be 3 times 3. 4 squared would be 4 times 4. 16 squared would be 16 times 16. So this theorem is used to find the length of any right triangle when the lengths of the other two sides are known. So if you know 2 of the sides of the triangle, then you're able to use the Pythagorean theorem to find the third side. So it might look like this. They might tell you how long this side is, and they might tell you how long this side is, but you're still trying to figure out what this is. So let's remember, all right, let's actually look back at the baseball problem. Notice they tell us how long this side is, how long this side is, but they don't tell us how long this side is. We would be able to use the Pythagorean theorem for that. Maybe they give you how long this side is, how long this hypotenuse is, but they don't tell you this. Again, you can use the Pythagorean theorem. Or they might be able to tell you how long this is, how long the hypotenuse is, but you're still missing one side. Notice the point is that in each one of these right triangles, you're missing a side. They give you 2 sides, but you're missing one. If they give you 2 sides and you're missing one, you're able to use the Pythagorean theorem to solve. Looking at this problem, we're going to find the hypotenuse. So, example 1, find the length of the hypotenuse of a right triangle if A is equal to 3 and B is equal to 4. So, as a reminder, the formula, the Pythagorean theorem, is A squared plus B squared is equal to C squared. So we know what C is. Let's label, they said A is equal to 3, so this is our A, and this is our B. So we know that if A squared, well, it says A squared, so we look at what's our A? Our A is 3, so we plug in 3, and we leave the squared. What's our B? Our B is 4. And we don't know what C is. That's what we're trying to figure out. So then we go ahead and solve this problem. So it's 3 squared. 3 times 3 is 9. What's 4 squared? 4 times 4 is 16. Then again, we don't know what C squared is. Now, 9 plus 16. 9 plus 16 is 25, and that's equal to C squared. Now, remember, anytime I have you guys solve for a variable, so for example, if I say solve for x, we want to make sure it's all by itself. The variable needs to be by itself. This variable is not by itself because it still has that squared. So what we need to do is the opposite. So remember how if we have addition, we subtract, we do the opposite. If we have multiplication, we divide, we do the opposite. So here we have squared. The opposite of squared is square root. That will cancel it out. But remember, whatever you do to one side of the equal sign, you must do to the other. So what is that equal to? And that leaves C is equal to, and then if you either plug this into the calculator or if you know the fact that 5 times 5 is equal to 25, your answer would be 5. Let's look at example 2. So looking at example 2, find the length of the leg of the following right triangle. So again, we know A squared plus B squared equals C squared. We don't know what A is. We know what B is, and then we know what C. Remember, C is the hypotenuse. So if we don't know A, so we put A squared. We know what B is, so that's 9 squared. And then we know what C is this time, so that's going to be 12 squared. Now let's go ahead and solve it. A squared, we don't know what that is yet. We know what 9 times 9 is, because again, 9 squared is the number multiplied by itself, that's 81. And then 12 times 12, that would be 140. Now, is A by itself yet? No, we need to get rid of this plus 81. How do we get rid of it? Well, we subtract it, we do the opposite. Whatever we do to one side, we must do to the other side. So 4 minus 1, that's 3. This becomes 13. Well, let's make it 13. There we go. And that leaves, since that canceled out, a squared. So again, when you have this, we need a all by itself. So what's the opposite of squared? It is a square root. Whatever you do to one side, you must do to the other side. And now this, no two exact numbers multiplied by themselves that we know of equal 53. So for this one, I would ask for you to just leave it as that. That is your answer. Again, unless you plug that into the calculator and it will give you a decimal answer. All right, so let's go ahead and, again, this is just additional practice. So this is, this would be a good opportunity for you to pause the video and go ahead and practice. And then I'll go ahead and quickly solve it. So if you did get a chance to watch this video, go ahead and pause it, solve it on your paper, and then come back. I'm going to go ahead and quickly solve this problem so you can see how it works. Find the length of the hypotenuse C when A is equal to 11 and B is equal to 4 as they labeled it for me. So I know A is 11, B is 4. A squared plus B squared equals C squared. I know that A is 11. I know that B is 4. And C squared, 11 squared. 11 times 11 is 121. 4 times 2 is 16. I'm sorry, not 4 times 2, 4 squared. So 4 times 4 is 16 is equal to C squared. I know that 121 plus 16 is 137. That's equal to C squared. Again, off the top of my head, I don't know, two numbers that when multiplied by themselves, or sorry, by itself is equal to 137. So what I'm going to do is I'm going to put C is equal to the square root of 137, and you can leave it as that. Let's practice with this problem. Again, A squared plus B squared equals C squared. So we look for what's our A, we don't know it. We know that our B is this, and this is our C because again, that's the hypotenuse. So our B is 5 squared, and then we know that C squared is 13 squared. So A squared plus 5 squared, that's 25. And then 13 squared. If you don't know what 13 times 13 is off the top of your head, you can either plug it into a calculator or on the side we can do multiplication, whichever way you know how to do it. So 3 times 3 is 9. 3 times 1 is 3. Bring down the 0. 1 times 3 is 3. 1 times 1 is 1. Again, this is a step you can take by, this is just sided work. You can use a calculator or you can just plug it in. 169. And then we subtract 25 by each side. That canceled out. And here I do know, again, to cancel that out, whatever you do to one side, you do to the other side. A number that when multiplied by itself is equal to 144, and that's 12, because 12 times 12 is 144. Looking back at our baseball problem, so it says a baseball scout uses many different tests to determine whether or not to draft a particular player. One test for catchers is to see how quickly they can throw a ball from home plate to second base. So that's this line right here. The scout must know the distance between the two bases in case a player cannot be tested on a baseball diamond. This distance can be found by separating the baseball diamond into two right triangles. So this is one of the, sorry for the lack of my straight line, no straight lines, but these are our two triangles. So we know what one side is, we know what the other side is, we just don't know what this is, and that's what we're trying to find out. So we can say that this is our A, This is our B, and we're just trying to find our C. So looking at this picture, notice I took one of the diamonds, and again, I labeled it. This can be my A, this can be my B, because they tell us those sides, and we're finding that one missing side, that's C. So we have A squared plus B squared equals C squared. So what's my A? What's my B? And what's my C? We don't know that. And then we would go ahead and what's 9B squared? So I know that 9 times 9 is 81, and then that would be 2 zeros, so that's 8100 is equal to C squared. Once you add those up, it's equal to C squared, and then you find the square root. Okay, we can plug that in. For now, I'm just gonna 6 square root of the. Once you do find it, you will figure out that the distance from home plate to second base is about 127 feet. Because 127 times. So what are your next steps? Your next steps after this class is to, if you have not done it already, complete the do now for today's class. Make sure to go ahead and complete the exit ticket that has the lesson. And then before class on Thursday, April 16th, make sure to complete the do now for that class. If you do have any questions, make sure to attend to office hours. I have office hours Wednesdays and Fridays from 2 to 3 p.m. You are more than welcome to come to office hours to ask any questions you may have. And I hope that you have a good rest of your day.